So let's, well, before we get to that, let's do one more definition I need to give you here. And that is that if you have an open interval I such that you have your real numbers in the function like we talked about before of C and F that are not continuous at C, then there are two categories of discontinuity, and we call them removable and non-removable. Those two categories exist. So when we find a discontinuous function, we have to determine if it's removable or non-removable. And what distinguishes those is the fact that a removable discontinuity can be removed, can be made continuous at a point by redefining. And what that means is this. We can take some functions, like say in a numerator and denominator, and we've done this before in a previous assignment, where we can cancel out factors. And when you cancel out a factor, it might remove an impossibility. So what is considered a discontinuous function, and rightly so, can be rendered continuous at that particular point if it cancels out. Okay? And so we have to identify that and go from there. Okay, so now if we take a look at number 7 on page 78, to help us get to that point, this says the limit as x approaches 5 from the positive side. So this is not x equals approaches positive 5, this is 5 approaching from the right going towards the 5. X minus 5 over x squared minus 25. Okay, now, what's the issue with this? Well, when we factor this out right here, this becomes x minus 5 over x minus 5 times x plus 5. That is the difference of squares. That means then that x cannot equal 5 and x cannot equal negative 5. However, because we have a factor here that can cancel out, this is going to leave us 1 over x plus 5. Now, if our limit is set at x over 5, we have rendered this then now continuous from that perspective. So if I want to find the limit as x approaches 5 from the right, this is then going to be 1 over 5 plus 5, which is 1 over 10. So our limit for number 7 is the value of 1/10. Number 11. Yeah, this is an interesting problem. I really wanted to do this one so you can kind of wrap your mind around how they approach their answer on this. And this is heavily dependent upon this negative part. It's coming from the negative direction going to 0, where this didn't really make much difference one way or the other, outside the fact that if we kept on the positive side, then we didn't have to worry about x being equal to negative 5. And so that wasn't going to be involved in the limit here, as we did over there. This was, we had to eliminate that based upon that definition, but not the case here. So, for this one right here, the function is the absolute value of x over s. Now, this is a real doozy. Now, these two are technically not reducible the way it's written. However, if we consider this in dealing only with the negative values of x's as we go across here, we know that these two numbers are going to be opposite in sign, right? In other words, if let's pick a number, let's say -2. So we put -2 over there, that gives me 2. If I put -2 here, that gives me -2. It doesn't change. And 2 divided by -2 is -1. Pick another number. Let's say -5. All right, so -5 goes there, makes that +5. -5 over here makes that +1. And that works really well up to 0. And since 0 is not included in this, then we are going to have to go up to that. And so this will say, because these numbers are opposite each other, this is going to give us a positive x over negative x. And that function then becomes equal to -1. The limit is equal to -1 up to 0. Now, at that point, it's still considered to be discontinuous if we include 0, but we have basically rendered it as being non-continuous if we don't include that 0. And so that's what's going on here, going from the negative towards the 0, and as it keeps approaching over there, it stays -1 all the way across, so it stays -1 at that point, and it stops right there. Doesn't go any farther. Because once you get past that, let's say we go +5, that becomes 1. So past that point, it was x0 positive, that would be a +1. So, you know, you need to try to wrap your head around that, but if you think about it, it makes complete sense. Number 15. And this is an interesting problem. This is a conditional function where you have two scenarios here, and this is x as approaches 3 on the negative side, and the conditions are x plus 2 over 2 when x is less than or equal to 3, and this is 12 minus 2x over 3 when x is greater than 3. Okay? Now, if we take a look at this right here, this tells us that this is not an option right here. We're not even going to consider that because that isn't part of our approach for the limit. So we're just looking at one part of it here. So if we do that, then as x approaches 3 from the negative side, that includes all this right here. We just plug in the 3 for this. This is 3 plus 2 over 2, which is 5/2. And so that is going to be our limit, 5/2. And again, this was a discontinuous function with the two of these together because at C, at 3, they changed. But when we eliminated this because of the approach that we used, we now have rendered this to be continuous up to that point. And that's what we're looking at. Number 19 rather. Sorry. Number 19, we have the limit as x approaches infinity of the cotangent of x. Now, this is going to come to trigonometry and understanding what your functions mean. I know that a lot of people struggle with radians as opposed to degrees, and that's fine. If you want to think of this instead as pi radians, think of this as 180 degrees to help you understand what happens here. That's fine. Also remember that cotangent actually means the inverse of tangent. Now, so the question here is, as x approaches 180 degrees, what is the tangent of 180 degrees? Well, tangent 180 degrees, if you look at the reference angle that's involved in that, the reference angle for 180 degrees, when I say reference angle, I mean how far away from the x-axis is this particular angle. And when I say x-axis, it can be positive or negative, either one, whichever one is closest. The closest one is on the negative axis side, and that's going to give you a value of 0, because it's going to be right on the x-axis. 180 degrees goes right over there. So that means that's going to be the same as the tangent of 0 degrees. But what is the tangent of 0 degrees? It is 0. And so now this becomes 1 over 0, which is undefined. So we say that this limit does not exist. There's no way that we can render this removable. It is what it is, no options, and that's all there is to that. Okay? So your practice problems are right here. Somehow they got erased, somehow they happened. Practice problems 78, 79, 2, 6, 8, 12, 16, and 20. Good luck.